All right, so let's look at how to make a truth table when you have a complicated statement. And now, if you're looking at this statement, you might go, oh, that is way too much to keep track of. I will not be able to tell whether this will be true or false just based on P, Q, and R being true or false. But that's not actually the case, and that's where truth tables come in very handy because they let us organize our information. And the key thing, like anything in mathematics, is break it down into its smallest parts. And here, if I look at this, really I'm talking about three statements, P, Q, and R. So I'm going to write those down because I know that when I'm looking at three statements, I'll be able to tell if these statements are true, false, or combination of true and false. So here, let's just write out all of the combinations for P, Q, and R. Well, I could have it where all of them are true. I could also have it where only one of them is false. And notice that that's going to lead to three different possibilities for statements being false, where R could be the false statement, Q could be the false statement, and P and R are true. Or it could be that P is false and Q and R are true. I could also have a combination where two of them are false and one of them is true. So P and Q are false and R is true, or P and R are false and Q is true. And what about P being true and the other two being false? And I could also have it where all three of them are false. And if all three of them are false, well, it's just false all the way across the board. Now that's all well and good. I found my three smallest parts. The thing is, that hasn't really told me if the overall statement is true. So what I'm going to look at next is what's the next largest group in here. And here I can see that not R is another thing that I'll need to know, is this true? So I can add not R to my table. And I know that just looking at R here, I can find whether or not R will be true, because it's just going to be the opposite truth value of R. So this will be false because that one was true. This one will be true because this one was false. And so on and so forth. And be careful that you don't mix any of these up, because if you get this one wrong, the whole problem will end up being wrong, even if it's just a little bit here. Well, okay, so now I know not R. But the thing is, I still don't know the overall thing. And if I look, the next biggest thing that I'm going to have to do is look at my parentheses. So let's find that one. Using only the combination from before, I have Q, and then the V, which remember is disjunction, not R. So what this is telling me to do is it's telling me to look at Q and look at not R, and just say, will it be true overall with the disjunction? And remember, disjunction is our friendly one. This is our or. And only one of these has to be true for this overall piece to be true. So here we have true because Q is true. The next one will be true because both of them are true. The next one will be false because neither of them are true, and so on and so forth. Well, now I'm really close. I have figured out everything in this statement, barring the entire statement. So let's take the whole statement now and look at that, because I now have enough pieces to do so. So I'm going to take P, conjunction, Q, disjunction, not R. And even though that looks maybe a little crazy, all it's really saying is look at the and or conjunction of P in our last column, Q or not R. And in this case, remember that when we're looking for and, we want both this part, P, and this part, Q or not R, to be true. So I'm just going to focus on those two columns, because those are the only things I'm going to focus on at one time. So in this case, we have true and true statement, which means that overall both are true, so I can put a true down in general. And for my second one, a true and a true statement, again, since both are true, I can put a true down. But our next statement, the or part, Q or not R, is false. So this overall statement would end up being false. And in the next one, P is false. So since one of them is false, the overall statement is false. And so on and so forth. And it turns out that what this table tells you in the end is when will this full statement be true or false. And I don't even need to know what P and Q and R are in order to be able to tell how the general pattern will go. And here I can see that if I have my original statements P, Q, and R as true, my overall will be true. And true, true, and false, where only R is the false one, will still end up being overall true. And a bunch of false ones leading us to this final one where if P is true, Q is false, and R is false, I'll again have a true overall result. And that can show us patterns that allow us to create more complicated statements and evaluate their truth value without even having to know what each individual statement is. We can still have an overall pattern that can be applied in a lot of different ways. But for now, I'm going to leave this to you. In your homework, which you can find on Classroom, number 36 is going to be very similar to this. Make sure you break it down into its smallest pieces and then build up until you have that large, full statement. Hope that helps. Have a good night.